Hello friends, thank you for liking and subscribing my previous video. Today I will be discussing logic gates. After watching today's video, go to the description box below. You will see a link given. Please click on the link and a Google form will open. Answer all the questions and see how much you can score.
Logic gate is an integrated circuit which is used to perform logical operations. It requires two or more input signals but gives only one output signal. Logic gates are digital circuits which work according to some logical relationship between input and output. You can see in the figure that we are giving a combination of input. The logic gate is thinking logically and accordingly the fan is switching on and off.
Logic gates are the building blocks of the digital system. They are basically used to perform logical operations by acting just like a switch. A logic gate accepts the input and operates on a required condition. If a certain condition is true, then it turns on, and if a certain condition is false, it turns it off. To understand logic gates, we will see all the possible combinations of input and what will be its output for individual gate in a tabular format, and this tabular format is known as truth table. Any number of inputs provided results in a single output with a minute time delay. Now let us take some real life examples to understand the OR gate in a better way. Let us take an example of a bulb in your room which is connected to two switches A and B in parallel, and this entire circuit is connected to a source. Now when you switch any one of the switch on, either A or B, then the bulb glows, and if both the switches are switched on, then also the bulb glows. The bulb is switched off only when both the switches are turned off. Here switch on implies 1, that means the value is true, and switch off implies 0, and the bulb glows implies 1, and the bulb when it is not glowing implies 0. And when you note down all these combinations in a truth table, you will see how the OR gate works. Now let us consider another example. Suppose in your home there are two bells, one at the front door and another at the back door. If someone rings the bell at the first door, that means in the front door, the bell will ring. And if someone rings the bell at the back door, then also the bell will ring. And if by chance two people come at the same time, one at the front door and one at the back door, and rings the bell, then also the bell will ring. This is how an OR gate works. Now this is the symbolic representation of the OR gate, where A and B are the inputs and A plus B is the output. In the truth table, as you can see that when the value of both the A and B is 0, then the value of the output, that is A plus B, is 0. But whenever either A or the value of B is 1, the output is 1. And when the value of both A and B is 1, then also the output is 1. If the number of inputs in an OR gate exceeds 2, it becomes a bit complicated to write down all the input combinations in a truth table. So let me share with you all a trick so that you don't even miss out a single combination for writing the truth table. Start from the column right hand side input column. In this example, there are 4 inputs A, B, C, D. So start with the column D. Write down 2 to the power 0 equal to 1 beside D. Now go to the column C, write down 2 to the power 1 equal to 2. Now go to the column B, write down 2 to the power 2 equal to 4. Like this way, continue increasing the power of 2 as you go from the right hand side to the left hand side column. If there are more number of columns, in this example there are 4 columns, but if there are more number of columns, continue increasing the power till 2 to the power n minus 1 if there are n number of columns. Now in this example, go to the first left hand side column, which is A. Here 2 to the power 3 is 8. So write down 8 zeros and 8 ones below A. Now go to the column B. Write down, since 2 to the power 2 is 4, write down 4 zeros followed by 4 ones till you reach the till you complete the number of rows. Now go to the column C. Here 2 to the power 1 is 2. So write down 2 zeros and then 2 ones, then again 2 0 2 1. Continue doing this until you fill the entire row. Enter all the rows. In this example there are 16 rows because the number of rows depend on the last left hand side column. Since here there are, in the left hand side column there are 2 to the power 3 is 8, and in binary number consists of 0 and 1, so number of rows will be twice 8, that means 16 number of rows. Like this way you can fill out the entire table without missing a single combination. And for writing the output, you know that if any one of the input is 1, the output is 1. So it's easy. Let us see 3 examples. The 2 vertical parallel lines is the logical OR operator in Java. Now, in the first example, the answer will be true because one of the first expression, that is 5 is greater than 4, is true. Although 8 greater than 12, the second expression is false, the result will be true, because if any one of the expression is true, then the OR operator gives an positive answer. That means the result will be true. Where in the second example you can see that both the expressions are false, so the result will be false. In the third example, you can see that the second expression is true, so the result will be true. Thank you so much for watching my video. That's all for today. And if you liked the video, don't forget to subscribe. And yes, don't forget to give the test, whose link is given in the description box below, and see how much you score. Thank you so much. Meet you in my next video.